Today's lesson, section 3.6b, talking about complex zeros and the fundamental theorem of algebra. So this is just an addition to that section where here if you have the sum and product of zeros, you can make a quadratic equation. So the coefficients of the quadratic polynomial is related to the zeros by the following formulas. So if you take the sum of the zeros, so also remember what they're talking about is the ax squared plus bx plus c quadratic formula, or quadratic polynomial. So the sum of the zeros, when you add them together, so that's what c sub 1 and c sub 2 are, gives you negative b over a. So that gives you that, kinda, and that. Okay, and the product of the zeros gets you c over a. So it gives you this one and this one. So now sometimes the reason why you have two fractions, they both have the denominator of a, so sometimes you'll have two different fractions with two different denominators, so you need to make them the same denominator, and then those will be your values that you get to use. So let's try this. So example 2, you're given the following zeros. You want to write a polynomial for each, so both going to be quadratics. So if I add them, negative 3 plus 2 gets me negative 1. And then negative 3 times 2 is negative 6. Okay? So here, they both have the same denominator of 1. Okay? So their a value is going to be 1x squared. And then, remember, the sum is the opposite of b, so I put plus 1x. And then on the bottom it's exactly the same for c, so it's negative 6. So here I have x squared plus x minus 6 as my polynomial. Okay? Same thing for letter b. So I add them, gets me 6. I multiply them, gets me 5. So then when I'm looking at my quadratic polynomial, I've got denominators of 1 again, so I get x squared, and then the opposite of b for the sum one, so it would be negative 6x, and then this the same sign for c, which would be 5. So I get x squared minus 6x plus 5. Okay. So now we want to be able to, given the following zeros, we want to write a polynomial for each where you have multiple zeros, more than 2. So here for letter A you have negative 1, 3, and 2 plus or minus the square root of 3. For letter B you have 4, negative 4, 2 plus I, and 0. So I'm going to show you two different ways. Let's try a different way for the first one. So here you have x. Now remember, you want to, like, these are all x equals. So it's like x equals negative 1, x equals 3, x equals 2 plus square root of 3, x equals 2 minus square root of 3. Okay? So I'm going to write these as binomials instead. So like move them back over. So it's almost like I say x plus 1 is equal to 0, x minus 3 is equal to 0, x minus 2 plus square root of 3 is equal to 0, and so on and so forth. So do that same thing. So write them all as binomials and just multiply them all together. Okay? And then here now you have the start of what you want. So you want to multiply your polynomials out. So like pick 2 and put them together. So I get for the first one x squared plus, plus 1x minus 3x minus 3. And then for the other one, if you want to distribute the negative through for both of those, so it'd be plus there. So then you get x squared negative 2x square root of positive square root of 3x, then negative 2x and then negative square root of 3x, and then you get negative 2, or negative 2 square root of 3, and then negative square root of 3x plus 2 square root of 3, and be negative, so you have square root of 3 times square root of 3 gives you 3, so it'll be negative 3 when you're done. So here a lot of things cancel out, so like the square root of 3 times x's cancel each other out, the negative 2 square root of 3's cancel out. So then now you can put like terms together, so you get two polynomials that are trinomials. And also a note here, whenever you have complex or imaginary solutions or zeros that you are multiplying back in, because they're the conjugate zero theorem, they're always going to cancel each other out if you multiply those two specifically to each other. So then you're left with real coefficients. So you won't have to worry about the radicals or the i's anymore if you do it like put them together, so the conjugates together. So here I'm going to multiply again, so x to the 4th, then minus 4x cubed, then x squared minus 3 minus x squared, and then negative 2x cubed, positive 8x squared, positive 6x, and then negative 3x squared, positive 12x, positive 9. Add these all together, gives me x to the 4th, minus 6x cubed, plus 2x squared, plus 18x, plus 9. So there's my polynomial for the zeros of negative 1, 3, 2 plus or minus square root of 3. Okay? So now for the other one, let's try, I'm going to use a different color here. So let's try a different way. So let's use the method that we had up there to help us. Now also, before we start, notice that I have 2 plus I as a 0. So that means, because of the conjugate zero theorem, 2 minus I is also a root or a 0. Okay? So I'm going to try my quadratic thoughts. So I'm going to put these together, and I'm going to put these together. Okay? We're going to leave this one just the 0 by itself for right now, because it will be easier to put that one together at the end. Okay, so here I'm going to add 4, negative 4, so that gets me 0. Okay, and then multiply, that gets me negative 16. Okay, so they're both over 1. So there's one polynomial where it's x squared, and then it would be 0x, so I don't have to put anything there, and then minus 16. So there's one polynomial. Okay, I'm going to do the same thing for my imaginary ones. So 2 plus I plus 2 minus I is going to be, the i's cancel out, so you're left with 4. That'd be over 1. And then 2 minus I times 2 plus I. So here you're multiplying, so binomial, so 4, 2i, negative 2i, so those cancel each other out. And then negative I squared. I squared, remember, is the same thing as negative 1. So minus a negative 1 makes a plus, so I get 5 over 1. Okay, just like I said, like with the complex ones and the imaginaries, they should cancel out, leaving you with a polynomial that doesn't have any imaginaries. So like that one's hard because the reason why it's negative 4x plus 5 is, if you think about the factors, it'd be 5 and 1. You can't add 5 and 1 to get negative 4. You have to subtract, and that's what the signs don't allow you to do. So now, we also want to include our 0 here. So that's when I'd say it's x equals 0. So I can just put in an x there, and now I can multiply through. So I'm going to put these together first. Okay, and now I just need to distribute. So x cubed times x squared is x to the 5th. Then I get negative 4x to the 4th. Then I get 5x cubed. Then I get negative 16x cubed. And then positive 64x minus 80x. Okay? And then I put them all together, x to the 5th, minus 4x to the 4th, minus 11x cubed, plus 64x squared, minus 80x. And then that would be my polynomial. So there's two different ways of doing this. You can use the sum and product formulas for zeros to kind of create quadratics, and then put your stuff together. Obviously, if you have an odd amount of zeros, then one of them's just going to have to be multiplied later like we did with the x. But that's not a big deal. But you can always just write them as binomials and multiply them out all the way. Okay? So, have fun.